circuits, which they were a part which they had never paid much attention to, and if it was economically profitable. So this is what they call a single line diagram of the auxiliary services. It's basically a transformer from high voltage to medium voltage. Then this is what they call a bus bar, and there are motors hanging from this bar. All the black things are motors, or actually groups of motors. And then we can have also transformers from medium voltage to low voltage and have some other motors working at low voltage. So this is basically one line of auxiliary systems. And there were three possible strategies. We could replace the current motors by high efficiency motors that will consume less energy. Or we can install what they call variable speed drives also at the motors. That means that the motors are presently, or were presently, working at full speed all the time, whether it was needed or not. And whatever was needed was wasted. Okay? And these variable speed drives allow the motors to work at the speed needed at each time, so we're not wasting energy. And then we could also install capacitors to compensate for reactive powers, which is a source also of energy consumption. And we could do this at each motor or at each bus bar as well. So we had to decide what to do according to these three strategies in order to maximize the energy saving after the improvements are carried out, minimize the investment cost, and maximize the internal rates of return. These were the three objectives that we considered. For the two first strategies,